Now we're going to move on to the mean value theorem. So this here is pretty much the mean value theorem here. At this stage, we're just going to play around with the concept of the mean value theorem. Later on, I will give you a formal theorem. Okay, so right at this stage, we're just going to play around with the concept of the mean value theorem. So suppose you have a function that is continuous and differentiable here. Let's say you've got this function here. What the mean value theorem is saying is that the mean gradient that exists between A and B, so the mean gradient would be something like this. The mean gradient would be, hang on. So the mean gradient would be the up and down here, which is this bit here, divided by the across. That's this bit here. So this thing here represents a mean gradient, okay, that exists between A and B. What it's saying is that there exists a value C, where C is in between A and B. So somewhere C is, it could be here, or C it could be here. The point is that there exists a C where the gradient of the actual function will be the same as the average gradient that exists between A and B. So let's say you've got any function. Let's just say this function here. What it's saying is that this bit here, you can think of it as being this line here. Okay, so let me just move this line all the way down here. Hang on. Let me just move this line all the way down here. So what it's saying is that, and then slowly move it up. What it's saying is that there exists a value C somewhere in between A and B. So there exists a value right here. Hang on. Right here. There exists this value here, right at this point here. So you see right at this point here. So in this case, our C is right here. There exists a point, or it could be more than one point, but the point is that there exists at least one. So right at this point here, the gradient of the actual function, which is this, will be the same as the average gradient that exists between A and B. Oops, hang on, bear with me. So this is your average gradient here, your mean gradient. You see, right at this point here, the gradient at this point is you see, this is the gradient of the actual function. So this is a gradient of the actual function. This is the same as the average gradient that exists between A and B. See that you see, okay, but the thing is that there could be more than one. You see, if you go all the way to the top, hang on. Let me move it all the way to the top and then slowly move it down. You see, there exists another point here. There exists another point here. So right at this point here, so bear with me. Right at this point here, this is a different C. We can call it C2 if we want. But the point is, there exists at least one. Okay, so there exists at least one point where the gradient of the actual function, that's this bit here, the gradient of the actual function will be the same as bear with me, will be the same as the average gradient here. Okay, so basically what it's saying is that it's like me asking you to bear with me. It's like me asking you to draw a continuous function between that crosses A and B. Now, no matter what function you draw, there must exist a point where the gradient of the actual function will be the same as the average gradient. Hang on, let me bring this up. You see, move it all the way. Oops, move it all the way down. Move it all the way down, and then move it up. Bear with me. You see, right at this point here. Right at this point here, bear with me, right at this point here, the gradient of the actual function will be the same as the average gradient that exists between A and B. You see, there could be more. So we continue with this, bear with me. You see, there's another point here. The theorem saying that there must exist at least one point, at least one. Or you could move it all the way to the top and then work your way down. Hang on. You see, there must exist a point where the gradient of the actual function. You see, right here. Hang on. The gradient of the actual function right at this point here will be the same as the average gradient that exists between A and B. So no matter what function you draw, It's like me asking you to draw a function that crosses f of a and f of b. So if you try and do something like this, okay, there must exist a point somewhere between a and b where the gradient of the actual function would be the same as the average gradient. So hang on, let me work. Let me slowly move it down. You see, right at this point here, right at this point here, right at this point here. So bear with me. You see, right at this point here, the gradient of the actual function would be the same as your average gradient. Okay, so no matter what function you draw, there must exist a point somewhere in between where the gradient of the actual function would be the same as the average gradient, except from when you do something like this. You see, this here is not differentiable. This point here is not differentiable. So you cannot. So the condition is that f of x. Hang on. The condition is that f of x here is continuous and differentiable. Okay. Yeah. Okay. We will explore more of this idea in the next video.